What's up, everybody? My name is Dana Harris with Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I'm going to quickly explain to you the inverse properties of logarithms and exponents. So we're going to go over the rule, and then we're going to do a couple of examples. So in the first case, where I have base A, we have log base A of a to the x equals x. Now, a in this case is a regular variable, so a can be any number. X can be any number, but based upon the properties of logarithms, we know usually this base taken to this power equals a. So what it's saying is if I have log base a of a to the x, that equals x. So the other case we have is if I have a to the log base a of x power, that equals x as well. And this is going to make more sense when I get into my examples, okay? The other case we have is when we have base e. Now, in this case, e is actually not just a regular variable. E represents a mathematical value. It's actually an irrational number, kind of similar to pi, okay? So, in this case, if I have base e, my first case is the natural log of e to the x equals x. All right. Ln represents natural log. I know that's kind of weird, but that's Ln, and it represents the natural log. All right. And then the second case, if I have e to the power of the natural log of x, that equals x. All right, so we're going to go ahead and apply these properties now. All right, so these are your rules. Let's go ahead and apply them. And we're going to keep these this video, the examples are going to be basic. So let's say if I have example 1. All right, and example 1, I have e to the x power equals 12. All right, now remember, e represents a mathematical value that you'll have in your calculator, okay? Whether it's a graphing calculator or a scientific calculator, that value is already in your calculator. All right, so here, if I want to find x, I need to take the natural log of both sides, okay? So I'm going to take the natural log of both sides, and now based upon my rule, the natural log of e is going to cancel, so I'm just left with x. All right, so x is equal to the natural log of 12, and when I calculate the natural log of 12 based upon the calculator, all you have to do is type in ln 12 if you're using a TI calculator. That is going to give me, and this is an approximation, it is approximately 2.485. Okay, so once again, in this concept, you're going to be using your calculator. All right, example 2. And remember, even in these, whatever you do to one side, we have to keep this equation balanced. So whatever you do to one side, we have to do to the other side. 2 to the x power equals 1.5. Okay, now if I want to solve for x, I need to take the log of both sides, because the rule says, so if I take the log base 2 of 2 to the x, then I need to take the log base 2 of 1.5. All right, so since I take the log base 2, this is going to keep me with x, and x is equal to the log base 2 of 1.5. All right, now the log base 2 of 1.5, I actually have to use the change of base formula because I don't know what power I can take 2 to get 1.5. So technically, what happens is 2 to the x power equals 1.5, as you can see. So here I'm going to say the change of base formula tells me log of 1.5 divided by log of 2. Okay, now when I have just log, that is log base 10. So I can leave it as log, or I can say base 10. Anytime you see log, and there's no value there for the base, it's understood to be 10. So log base 10 of 1.5 divided by log base 10 of 2. Once again, these values come straight from the calculator. It is approximately 0.585. And I leave it in this form because when you are approximating, it's best, you're going to get the best estimation by keeping it like this. I could actually calculate what the log of 1.5 is and the log of 2 is, but it's best if I put it in the calculator just like this with the proper notation to get the best approximation. Okay? Moving right along. So let's go to example number 3, or as I like to say, tree. Example 3, we have the natural log of x is equal to 4. All right, so I need to figure out what x is. So the natural log of some number is 4. Well, I need to take this and raise it by e. Okay, I'm going to raise both sides by e. So e to the natural log of x power is equal e to the 4th power. Once again, e is a value in the calculator, and the button usually looks like this. E to the x power. Okay, so you press that button and it'll automatically bring it up. All right, so then now if I take this, this is going to give me just x because those cancel, equals e to the 4th power. All right, and so x is equal to e to the 4th power. I can get that approximation from the calculator, and it is approximately 54.598. Okay, now remember, when we're approximating, like I said, your values may be slightly different depending on how many decimal places you're rounding your answer to. All right. Example 4, we have log base 2 of x equals -1. Okay, and so in this case, this is a little different. So we're going to use our basic rules of logarithms, and we're going to rewrite it in exponential form. Okay, so what that says is this base 2 raised to the -1 power equals x. Okay, and now that we have it like this, now we can work on this. So we want to think about it. 2 to the -1 power is actually 1/2. So we can calculate that, and 1/2 equals x. All right, so that one was a rather easy example. Let's do one last example that is kind of similar to example 4, because sometimes a lot of people overthink these, and some of them you will have to think thoroughly, but then other values we have to go back and remember we can change them from exponent form to exponential form or logarithmic form. So in example 5, let's do log base 10 of 2x is equal to 1.5. All right, so we want to make sure that we use these rules. So I'm going to write this as in exponent form. So 10, this is my base, to this power equals 2x. To the 1.5 power equals 2x. Now, in order to find x, think about it. We have to balance it. I want to get x by itself, so I want to actually divide both sides by 2. Okay, so that tells me 10 to the 1.5 power. We're going to keep it just like this, because this is how you want to put it in your calculator to get the best approximation. And if I put in my calculator 10 to the 1.5 power divided by 2, I'm going to get approximately 15.811 is my approximation of x. Okay, so notice on these last two examples, we didn't have to use, we really just rewrote it in exponent form and took it from logarithmic form. Thank you so much for watching. Please do me a favor, like the Facebook page, Young Gurus Math Tutoring. Follow me on Instagram at YG Math Tutoring, as well as please do me a great big favor. Subscribe to this YouTube channel. I hope these videos are adding some value to you all. Share them with someone else. Please don't be afraid to repost the content and things like that. I want to help students all over the world understand, learn, and just do better, have a better appreciation for mathematics. Thank you so much. And I've got the solution. I can't grab my shirt, but I got the solution to your math problems.